All right, hi, I'm Julius. I'm one of the co-founders of the Prometheus monitoring system and a founder of PromLabs, a company that offers products and services around Prometheus, including a query builder called PromLens, which I will talk a bit about later. But first, I'll talk about best practices and pitfalls when you're doing monitoring with Prometheus. And then later on, we will actually see how you can use PromLens to avoid some of the pitfalls that I'm going to talk about today. All right, so Prometheus in ancient Greek mythology was a titan, and he got famous or infamous for stealing the fire from the gods and bringing it to the humans. He wasn't allowed to do that. So, the gods actually didn't like that very much, and they punished him in the end, tied him to a rock where for all eternity an eagle would come, eat his liver every day, the liver would regrow, and then the eagle would come again and eat his liver. So not a very nice ending for him. And it's similar with Prometheus monitoring. Sometimes it feels more like in the first picture, and on bad days when things go wrong, it feels a bit more like in the second picture. So this talk is for making you feel more like in the first picture where everything is good and there's light. I will talk about a couple of areas here. Instrumentation, so what to think about when you actually add metrics to your services. What to think about when creating alerting rules. Best practices for alerting, and then also topology, basically the monitoring architecture, typical things that can go wrong there. Let's talk about metrics and instrumentation first. So there's some general pieces of advice first about what metrics to add to the services that you're monitoring, or the things that you're monitoring if they're not services. Two popular methods are the use method and the red method. You may have heard of them. So whenever you have a thing that looks more like a resource, like a queue that can be empty or full, or a CPU that can be idle or busy, or a disk also that can also be empty or full, then the use method is a good guideline for what metrics to add. So basically there you want to track the utilization, the saturation, and any errors that are occurring with that resource. When you have something that looks more like a request handling service, like a web server or a database server, something like that, then the red method is more applicable. So there you want to see how many requests or events are you actually handling in total, how many of those are errors, and then also how long does it take to handle them. Potentially in some distribution, like with a histogram telling you how many requests of which latency category you are handling. With Prometheus, metrics that don't have any separate label dimensions on them are really cheap. So there I would advise you to really spread them very liberally in your code. Everywhere where you typically would have had a log line to log that a special event is happening, especially for errors, don't even think about it. Put a Prometheus counter metric there, just saying increment every time that piece of code is hit. It gives you a lot of valuable information about what's happening in your code, and it doesn't cost a lot. Also, if you have common libraries that you share between your different services, it can really make sense to put metrics directly into those libraries, so you automatically have them in the applications that use them. So Prometheus itself doesn't do that much with the metric type and unit information. There is no unit information yet even, but metrics do kind of have a type on the wire when they're sent from the client library. So the metrics say whether they're a counter, a gauge, a histogram, or a summary. But then PromQL is not really a language that even can look at that type and make sure that you're using the metric with the right type. So since there is no static enforcing of this kind of thing in Prometheus, the next best thing that we can do is, as humans, as people who create metrics and then people who use metrics, to use certain conventions and stick to them. So we have written down some best practices around that in the Prometheus documentation. You can see them down there at that link. But, just as a couple of examples, have a unit suffix in your metric. Tell me if it's bytes, if it's seconds, if it's number of items, whatever it is. Make it clear what the unit is. And then also, as a general practice, try to stick to base units. So SI base units, use seconds instead of milliseconds, use bytes instead of megabytes, and so on. This just spares you a lot of conversions, especially if you do arithmetic between different types of time series later on. It's nice if you know immediately, okay, yeah, everything is in seconds, everything is in bytes, and so on. To make it really clear to the reader which metric is either a gauge or a counter metric, only counter metrics should have an underscore total suffix. So if you create an explicit counter, add an underscore total counter suffix, and don't do the same on a gauge that maybe just exposes the current count of something, like a length of a queue. This way, I can look at your metric name and I can immediately see that, this is a counter or not. Obviously, there are some counter metrics that are auto-generated, for example, by histograms and summaries. They have underscore count, underscore sum, underscore bucket. Those are special counter metrics. These will, of course, not have underscore total as a suffix, but you still know immediately when you know a bit about Prometheus, you know what they are. There's also a good rule of thumb for what to put into a single metric name. When you have a metric name and you have many time series in there that are differentiated by a label, what do you put into separate metric names versus what series do you put with under one metric name? And a good rule of thumb is that it should either make sense to sum or to average over all the different time series of that metric name. So let's say you have a lot of CPU rates split up by the different CPU modes and CPU cores. It would totally make sense to sum over all of them to get a total system CPU usage. But if you had, for example, a memory metric that had also a type of memory usage, like system usage, user usage, and then also type equals total, then if you summed over that, you would add the total to all the other modes, so you would basically get the total twice in the end. So that would be a bad metric structure. You would leave that total out of that metric and instead leave the totaling up completely to the sum operator. That makes more sense. So this is just a guideline. Of course, there will be some exceptions. If you want to know more, have a look at that link down there. Another common newbie problem is that once you start using Prometheus, you discover the concept of labels, and labels in Prometheus are awesome. They allow you to really create highly dimensional data, to be able to drill down into details of what is happening. That's nice, but a label also can, each unique set of labels creates one time series in Prometheus, and Prometheus, one server can only handle a limited amount. I'll talk about what that is. But basically, if you put something into a label value that can have an unbounded, very large number of different values, you may blow up your Prometheus server. So if you put public IP addresses in a label value or user IDs, or at SoundCloud, for example, someone put full HTTP paths in there, and the HTTP paths actually contained a SoundCloud track ID, and there were millions, like 100 million SoundCloud tracks. So this immediately blew up the Prometheus server. So keep the values of your labels well bounded in such a way that they cannot have too many different values at a given time. And keep in mind that all these different labels that you have on a metric multiply together. So if you have a metric that has, it's splitting up HTTP requests by status code and by path, and you have 10 paths and 10 status codes, they multiply and you have 100 series. And then if you have 10 targets, it multiplies by 10. So you have 1,000 series already just for that one metric. So keep in mind how that multiplies together. Ultimately, though, there's no really hard rule for how many different values you can have on a single label name or how many series within one metric name. What really matters is what your Prometheus server can handle and how you're going to query it. So a large Prometheus server can handle maybe a couple of million time series. But then also you have to think about how to query it. So typically in a PromQL query, if it's a table-based query, you may still comfortably be able to show 10,000 metrics or so in a table. But in a graph, you already want to show less and maybe even process less before showing it. So, you have to kind of keep in mind that you are going to have to access all the series belonging to a given metric name for a given query, for example. And if there's too many series in there, like 100,000 series just for one metric name, that is probably going to cause a lot of problems during query time. So do this math in your head, choose your metrics, your labels, and the number of service targets that you're scraping accordingly to stay under these two budget points. Another thing, when you first start using Prometheus and you're basically instrumenting a service that is handling requests, then a common thing that happens is that you think of how to categorize these requests and counting them in that way. So you have successful requests and you have failed requests. And your first instinct might actually be to have two counters that represent exactly that. So you have one counter for failures and one counter for the successes. But if you think about what you actually typically want to do in the end is you want to show a ratio of how many errors are you having versus the total number of all requests, including the errors. And doing that in PromQL now becomes complicated because to calculate the total, you have to sum up the successes and the failures, and then your ratio expressions can get quite complicated. So a better practice is to, instead of the successes counter, you have just a generic requests counter that counts all requests. And then your ratios immediately become much simpler. And also in general, when you want to graph total requests, you don't have to when you don't even want to do a ratio, you don't have to sum anything up either. Let's talk about normalization of metrics. In general, in your instrumentation, the labels on a metric should all serve to identify that metric and shouldn't just be there to give you extra information about, let's say, the service process that is exposing the metrics. Sometimes people want to, for example, expose the specific role of a server in each time series that server is exporting, like the CPU usage, the memory usage, etc. All would have a role equals DB server a label. And that's not actually needed to identify just that metric. It's just giving you a bit of extra information about the actual host, the instance it is coming from. The problem is when that host now, in this case, changes its role, then these time series also all change at once because a time series is identified by its entire label sets. So the time series now all stop in midair and the new ones begin also in midair, and there's a discontinuity and that breaks things like rates and other things that calculate things over time. So in general, it's a better idea to have just a single metric on your process that exposes some meta information and then join it in only when you need it. Again, helpful blog post by Robust Perception down there to tell you how exactly that works. So let's talk about alerting. There's a famous Google doc by Rob Evershook, who also used to work as a site reliability engineer at Google. This Google doc, though, already became famous outside of Google as well. And, it's quite long. Check it out. Just, Google for my philosophy on alerting. But just to summarize some of the main points. In general, it's better to alert people on really user-visible symptoms. Like, is the site down? Is the site slow? Does it show errors? Is some email system not sending emails to users? This kind of symptom that the users of your service or system would really care about. And don't try to alert on every potential cause that could cause a problem. Like, is there a lot of CPU usage? Is the load average high? Like that kind of signal. It's quite noisy. It would give you a lot of false positive alerts. and would make your on-call person really tired, and then they wouldn't do a good job anymore. There's an exception, of course. If there is a possible cause where you're really confident that it will cause user visible problems very soon, like your disk being full within the next 4 hours, then that's still something you want to alert on, of course. Generally though, try to send fewer pages than more, because you tend to actually have more energy than to look at individual pages and try to fix them, and you avoid on-call fatigue. Still, collect the underlying causal metrics as well, because once you're paged, you still want to have them like load average and CPU usage and so on to actually potentially figure out what the reason for a breakage is. Okay, let's get more Prometheus specific again on the alerting front. Imagine you have a service that is handling requests and you want to send an alert when there's a high error rate. So you could take the errors total metric, you take a rate over that over 5 minutes, and you say if that rate is larger than 10 per second, and that's true for 5 minutes, then send me an alert. So that works. But have you thought about what happens if Prometheus cannot scrape the targets that this metric is coming from, the my job targets, or if it's maybe not even configured at all in your Prometheus server, or the service discovery is not sending any targets for it, although it should? What will happen then is that this errors total metric will stop existing completely, and the alert metric will, the alert rule will have an empty output, and an empty output for alerting rules means everything is good, like I don't need to send an alert. So in that case, you would never get an alert. So basically you want to check that your targets are really being scraped properly. And there's 2 different things you want to check here. So for every service that you really care about, I would recommend you to have these 2 types of alerts, or for each job, let's use that terminology. The first one is, whenever Prometheus does try to scrape your job targets, it records a sample value with a metric name up and the value of 0 when the scrape has failed, and 1 if the scrape was successful. And the labels on that metric name will be the labels of the target that was being scraped. So you can tell in detail like which target is currently being successfully scraped and which one is not. So always have an alert on this up metric telling you when it's 0 for a given job. You can have different variants of this, so you don't necessarily have to test that exactly each target of that job or is individually at 0. You could also say, if a given number of them is at 0, a given ratio or whatever makes most sense for your target. But do check that this up metric actually, that not all the targets of your job are actually down. But then secondly, that up metric will also only get created when Prometheus is even trying to scrape your target. So imagine if Prometheus had a problem talking to service discovery, or you had misconfigured it for some reason, and it wouldn't actually even try to scrape the my job targets, then there would be no up metric for that job. And even that up alert would completely produce an empty output, although it shouldn't, right? So for that, to detect that kind of situation, you can use the absent function to tell you whether the up metric for that job doesn't even produce any time series at all. So the absent function kind of inverts the input. In the case where the input is empty, it will return a time series, and otherwise it will not. So basically it generates an alert when there's an empty input. So have these both of these alert types for each job that you care about. Let's talk about for durations. First, here's an alert definition again that does not have a for duration. Alert name is instance down. I want to alert when an instance cannot be scraped. And I'm achieving that by checking if the up metric is 0. The issue here is that now a single failed scrape can actually cause an alert already. If Prometheus encounters the up metric being 0 a single time. And this can happen a bit too fast, like a network outage, a very brief one, or maybe the target is restarting and I'm just catching it in the restart time. and thus I cannot scrape it in that 1 second. So probably you don't want to immediately alert, but add some kind of tolerance there. For example, saying this has to be true for 5 minutes before you actually should create a really firing alert from that pending alert. Similarly, if you have an absent alert on your up metric, if that Prometheus server is completely fresh or it hasn't been started for a while and now you start it will maybe not even have the up metric yet for that job, and maybe your recording rule or the alerting rule will already run and it will see like, hey, that up metric doesn't even exist. So it immediately sends you an alert. Again, something you want to avoid. So there, again, to make it smoother and more tolerant, add at least something like a 4-5 minutes duration. In general, keeping this at least at 5 minutes is a good idea. For most alerting expressions, unless you know what you're doing. You could, I guess, send it to like 1 minute or 2 minutes as well if you need to react really quickly, but typically don't keep this at 0. You probably don't want to make it too long though. So some people think it's a good idea to have a 1 day for duration. That used to be a really bad idea in the past, where Prometheus wouldn't remember the different alert series states over Prometheus server restarts yet. So if your Prometheus server restarted more frequently, then if your Prometheus server restarted more frequently than your for duration was long, then it would actually never alert you on anything. So that has been fixed. Prometheus now stores that information across restarts, but still, you may lose bits of your local storage. You might have to start a fresh Prometheus server, and then it would lose 1 day of necessary state. So try to avoid that if possible. Like a good maximum duration for reasonable alerts typically would be 1 hour. Another common thing is when you have an alerting expression and you want to have an aggregation in there, and you use a sum, average, min, max, one of these operators that aggregates, then whenever you don't explicitly keep a specific label, it will be aggregated away. Even labels that might be really helpful to keep and that are the same across all the time series that you're aggregating over. For example, if you are aggregating over the different rates of one service, they all have the same job label, and it might be really handy to keep that job label so you can use it later on when the alert gets sent to Alert Manager, and then you can base your routing, your grouping, the silencing, and so on that. So, try to keep with the by operator. In this case, the by modifier, you could explicitly keep at least job label, or even better, if you use the without modifier on an aggregator, it keeps any labels that you don't explicitly aggregate away. So this is even better in most cases. Okay, let's talk a bit about PromQL, how to query properly. One first simple thing, the metric names that exist in Prometheus typically only have a given meaning within one program or binary or code base. So typically this would be within one job, right? Because typically a job is a set of replicas of the same service that all run the same code. And that within that same code, let's say the HTTP requests error total metric has exactly one meaning. Now there could be a different service by a different team which has the same metric name, but it has quite a different meaning, or maybe just a slightly different one, maybe even the same. You're not sure, right? To be sure that you're selecting only the metric that you really care about and that has a specific meaning, it's a good idea to namespace it properly. So typically that will mean appending a job equals something something selector to your metric name to make sure you're not accidentally also selecting metrics that you don't intend to select. Another common thing, using counter functions with gauges. So there are some functions in PromQL that only work properly if you put a counter metric into them. Again, as I mentioned earlier, PromQL cannot actually tell really in a static, strict way whether a time series is a counter or a gauge. But these functions, rate, irate, increase, and resets, they assume that the data that you pass into them has the shape of a counter. So that, for example, a counter can only go down if it's a full reset, if the process that tracks the counter has a restart and it starts again at 0. But normally a counter can never go down. So let's say the rate function, right? If you take its 5-minute rate window and you look at it looks at all the different samples under that window, and it starts at the oldest ones and kind of goes through them to compute your rate. And if it ever sees one sample having a lower sample value than the previous one, it will just say like, hey, this is a counter. It cannot normally go down. So that must have been a counter reset. So I will pretend as if that reset had never happened. And you can see these in this diagram. The black samples are the physical ones, and the blue ones are the counter-corrected samples, where the rate function pretends as if that reset had never happened, and it basically neutralizes them away. And it will, in the end, always give you only a positive rate and not a negative one. So if you put a gauge metric in there, which can naturally go up or down, the rate function will still think, for every time it goes down, it will think it was a reset, which is not semantically true anymore. So it will not actually give you an error because it cannot really detect that it's not a counter metric, but it will give you a wrong result. So be really aware of that. Similar, the other way around, there's some functions that work only for gauges and not with counters. So if you want to know how fast a gauge metric is going up or down, you could use the derivative function, the deriv. Tells you how much per second it's going up or down. Or the predict linear function tells you where a gauge metric is predicted to be in the future based on its past development. And if you use those functions with a counter metric as an input, they will also give you bad results because these functions explicitly don't have any special meaning for when a value goes down. So they will not correct any counter resets that happen. So, you will also get bad outputs from them, but also no error. Another thing, when you have rates or similar functions like increase or deriv or so over a time series, you have to specify windows. I'll stick to the rate example here. So you have to specify what time window to calculate the rate over. But in order to calculate a rate, you need to have at least 2 data points under the provided window. And you need to make sure that that always is the case, because otherwise you will get an empty output at that point in time. So what happens if, under your rate window, normally there would fit 2 samples, but let's say there's one single bad scrape, then immediately you get an empty rate output, and you don't want your rate windows to be so, unrobust. So it's a good practice to keep your rate windows at least 4 times the scrape interval to make them robust against small issues such as a bad alignment of your rate window in comparison to the actual physical samples and potential bad scrapes under the window. It's nice to kind of be sure that you always have at least 2 samples under the window to create a rate from. So generally, try to make your rate windows at least 4 times your scrape interval. Let's talk a bit about topology in monitoring. So some architectural problems that people often run into. One question is whether you want to have one large, I call it Uber exporter, for many different things at once, and then have Prometheus scrape only that one large exporter, or whether it's better for Prometheus to scrape many little targets, every process individually. So let's look at this. In the first case, we have this kind of large Uber exporter where, let's say this is a host and you have 2 web applications running on there from a different team, the MySQL database server. You're exposing some host metrics and then also resource usage metrics about that, like all containers on the host. And maybe you're thinking, okay, let's all push that to a central exporter on that machine first. or potentially that exporter could pull locally. It doesn't really matter. It all goes into that central exporter first. And then Prometheus only needs to scrape that one large exporter, which, at first you could think it actually makes everything better and easier. The downsides here, though, is that single exporter really becomes a bottleneck, and when it fails, there's no isolation between the metrics of the different services. So when one service sends too many metrics, for example, and kills the exporter, then all the metrics of the other services will also be affected. And as the Prometheus server operator, you may want to selectively scrape only some of the services. For example, maybe you're the MySQL database administrator and you only want to scrape the MySQL database and the metrics from that. Now you cannot easily do that, right? And with Prometheus, it's also quite nice normally with the pull model when it can go directly to your target. It can record that up metric that I talked about earlier with a value of 0 or 1 very specifically for a given target that it is scraping. Now, the only target it's scraping in this case is the exporter, so it kind of loses the value of the up metric a lot, right? So you'd have to check the health of these things, whether they're really still pushing their metrics in a different way. Also, when Prometheus discovers targets from service discovery, it typically gets a lot of useful label information about the target, what environment it is, what type of target it is, and so on, and it can attach it automatically to all the time series that it is scraping from a target. So this kind of association of service discovery metadata to your metrics becomes harder now. So a better approach typically is to really have very fine-grained exporters. Like next to every little thing, every process that you care about, have an individual exporter, or in the best case in the web app up here, even instrumented directly with the Prometheus client library, and have Prometheus scrape it directly. And then you get rid of all these problems. So you get rid of this one central bottlenecks. If one app starts creating too many metrics, I can still choose to just not scrape that anymore. So I might not get any web app metrics, for example, anymore, but I still have the others. I get the very fine-grained up metrics. I get on the metrics pulled from each target, I get the proper labels. So make it possible for Prometheus to go to your targets in an as direct way as possible. There's a similar problem that can happen when you use the push gateway in this way to try to transform Prometheus into a general push-based system. So you also want to avoid that. There's more details in the in the linked article here that I wrote on the Prometheus.io docs page. Okay, so finally, there's also, the abuse of the federation feature of Prometheus. Typically, the federation feature in Prometheus is meant for only pulling a small subset of metrics from one Prometheus server to another. Or for hierarchical federation, where you have a global Prometheus server that does not have all the detail, but global aggregations, and you have multiple detailed local Prometheus server, let's say one in each data center, that has the full local state, but not the global one. But some people think, hey, this is a good idea for actually replicating an entire Prometheus server. The issue is, so basically, selecting all metrics in a remote Prometheus server and pulling them over into yours and storing them. The issue is that this federation protocol was really not meant for that. So the endpoint to federate is basically like a normal scrape, and it would get really large and also really expensive to compute on the Prometheus server that is, being pulled from. So typically that starts breaking down if you, pull too many series at once. So, a couple of 10,000 series might still work, but don't federate millions of series. Okay, so as I promised earlier, I want to demo the PromLens query builder a tiny bit and show you how it can be useful. So for that, I will switch over to promlens.com. So this is a commercial product by PromLabs, my company. You can run it locally as a Docker container, and if you get a license key, you can unlock actual like commercial features in it, like a Grafana integration. But just to give you an idea of what it is, it's an explorer, builder, visualizer, analyzer tool for PromQL expressions. So as normal, you would type your PromQL expressions into a field, but then PromLens shows you the structure of the PromQL expression as a tree. And it shows you for each node of the tree how many different results there are, what the different label names are, how many different values they have, and so on. And then, just scrolling down a bit to show you this, obviously it also has really good syntax highlighting, auto-completion, all that. You can, if you want to, edit each node in the tree in a form-based editor. It also shows you exactly where in the tree some error occurs if you've gotten something wrong in your expression that is only happening during runtime. You can easily see which label names have what types of values. So for each label name on each sub-result, you can easily kind of, like with a metal detector, hover over everything and check what types of values you're working with, which is really important when you are building more complex PromQL expressions. So this can really help you just like understand the data you're working with in a larger nested expression. It also shows you certain hints and actions. I will demo that in a second. Basically, you can connect PromLens to any PromQL compatible API endpoint. So this could be Thanos, Cortex, Timescale, and other systems that implement PromQL compatibly. And then it just talks over HTTP to that system. The nice thing is also to check what data you're working with is you can click on each node in that tree independently and see for that sub-expression of PromQL, what is the actual data you're working with, which is really, really helpful because like if you only have one large expression and it just does not produce an output, for example, you might be wondering why is it not producing an output, which sub-expression is already empty maybe that leads to that. So this helps you really quickly find the reason for that. It also has an explain tab, which shows you basically the meaning of each node that you highlight. So it can even explain binary operators here and how they match things on the left and right hand side. It has a metrics explorer that shows you the type and the help string for each metric. And then you can insert those metrics into your expression. You can, deploy it as simple as this. And you can even share links with your teammates. This is a feature which you only have when you get the license key, and also connecting it to a Grafana installation is also only possible with a license key. What happens then is basically you get a drop down at the very top of PromLens where you can select Prometheus data sources that are defined in Grafana. So you don't have to manually enter a Prometheus URL at the top. So just to give you an idea of what this actually looks like and what it can do, let's go there. So there's a demo running at demo.promlens.com. And basically we type in any expression as usual. And let's say we build an expression. We see that it generates this tree immediately. I can switch into inline PromQL editing mode, change something if I wanted to. But I could also switch into a form builder and, for example, say, hey, I want to keep also the instance label in this aggregation. So I put it in here, apply the change, and now I have the instance label in my aggregation. I can check that here. It can also explain what's happening, as I mentioned, right? For every type of node, it knows how to explain it. It has all the function documentation in there. And then going back to what I mentioned earlier in the presentation, using counters in rate functions or using gauges in counter functions, it tries to detect those situations as well. So if I have a rate function, and let's say I put something like a memory usage in there, because I want to see how quickly the memory usage is going up or down, it will show me a little warning here telling me, hey, this metric name does not end with a suffix that looks like a counter, so it's probably a gauge, and you're only meant to use rate with an actual counter metric. So, it gives me this error, and it also gives me a button here to automatically fix this problem. So now I fixed this problem, and let's say we do it the wrong other way around. So we put a counter metric into the deriv function. It doesn't exactly know whether I want rate, irate, increase or so, but it can tell me again that I'm making a mistake, most likely. So I get these handy quick action buttons on here. I can edit the tree in quite flexible ways. In general, this really helps people get the most out of the expression building process. And if I go to another example here, I have a binary operator here that I'm visualizing. It's this one here, visualized in the tree. Then PromLens can really show me on the left-hand side and the right-hand side how this binary operator matches series together and how it produces a result. So I hope this demo was useful for you, and that maybe some of you will be interested in trying out PromLens. Just write me if you're interested in it. And you can also try it out on Nextclipper. By the way, there's a button to launch a PromLens instance in a Nextclipper cloud instance once that's available. Okay, cool. Thank you very much.